Now that we know what arrays are, let's go ahead and do an example where we actually program with them. Here I've taken one of our old programs that we wrote. It was the one for when we were doing file IO, and it was the readnames.cpp, and what this did is it took a list of names, which I have here. So it takes any text file that contains some number of names that we don't know, and then it just printed them to the screen. And so instead of printing, what I like to do with this list of names that we have here is instead read them into an array, and so we can store all of the names kind of just together right next to each other and then be able to access them later in our program if we wanted to in a pretty easy manner. Right, so let's go ahead and do a few things so that we can declare this array. We said previously that arrays can only be one size after you declare them, at least if you're using static arrays like we are going to be doing in this class. And so what I think is a good idea is to create a constant that represents how big your array should be. So here we'll say max size, and for the sake of this example, we'll make it 10. Now, the problem with doing this, right, is the fact that if we make it the same size every single time, then we might be wasting some space, and we might also run the risk of it not being able to read everything. So here, if I make my max size to be 10, we know in advance that this list contains 4 people, but that's not always going to be the case. What if we get a list of 20 people? Then my max size is not big enough. And so we have to kind of have some idea if we're going to do static arrays like this, where we maybe pick a number that's bigger than what we expect to happen to occupy our array, but we don't pick a number that's too small that we don't be able to read everything, right? So if I picked a size of 2 of this array, then it wouldn't be able to hold all 4 of those names that I have in this file. So I'm just going to pick 10. I think that's okay. And then we are going to create an array here. So I'm going to create an array, and we know that it's going to be an array of strings, right? Because we know that the string is going to be all of the lines that we have here. And I could modify this and do some things with the name and just put it directly into the array, but I'm going to keep everything pretty much the same here, and we're just going to create a string array called names are, and then we are going to make it max size big. So remember that this is how we create an array. We just put these little square braces, and then we put how big we want the array to be. So this will make an array of max size. And then what I think we'll also need to do is we will need to keep track of a variable of what the actual size of the array is. Now consider that in this example, we are only going to have 4 names in that file, right? And so if I was to try and access all 10 of those, consider that the first name is going to go in element 0, the second name is going to go in element 1, the third name is going to go in element 2, and the fourth name is going to go in element 3. So those are going to be the 4 indices that we have. So if I tried to access, index 4 or 5 or 6, anywhere from 4 to 9, then it's going to be out of bounds of what is actually valid data that we've actually assigned to it, but not out of bounds of the array. And so I might end up getting some kind of a read error if I try to use things that are beyond where I've actually read, because I have this extra space, right? If I allocate the array to be the size of 10, and there are going to be 4 names, then there's going to be 6 empty slots to the right of those 4 names, and so I don't want to be accessing that. And so what I do is I am going to keep track of a count. Actually, let me just call it length, and this will tell us how much is actually occupied in terms of our array. So here we'll say this is how many things are actually in the array. And we are going to have to calculate this ourselves. Now here we have this code that we've written previously, and so it checks what is the argument count. Here we said that the usage of this program was the file name that we want to read from, so we're going to have to do that when we run the sum command line. And then we opened that file with that file name, so we created an if stream called list file. We opened that list file using the file name that we got from the user. We made sure that the file opened just for the sake of our program, and then we went down here and we started reading. I actually already have I here, which does the same thing as a count variable I had above, so I'm just going to delete it for the time being. And I'm going to use this instead. And I probably need to count plus plus. Yeah, there it is. So we're going to use this to count how many names there are. Oh, right, I renamed it to length. My bad. Right, so all this did, right, was we were initializing the length to 0 because by default, if we haven't read anything, the length of our array, or like the number of things that are in an array, is 0. And then after every single name we read, we will print out the name, is what we were doing previously. I think we'll just drop that here. We'll move it to later. And we're just going to increment the name. Now, this line is what actually grabs the name, right? GetLine just reads a line from a file, so it goes all the way until it hits an end line. It reads spaces. It will read any other kind of white space, just not line feeds unless we tell it otherwise. And so this right now is just grabbing each name as a refresher. So right, this is going to grab this first name, this whole name, and then this one, and then this one, and this one. And so what we want to do is we want to put them into our array. And so I should probably move some things around. I'm going to move this length plus plus down below here, and I'm going to use the array right above it. And the reason I'm doing that is because length is starting at 0. So I initialized it to 0, and if we consider that the array also starts counting at 0, then it would make sense for me to use the length to put the thing into the array and then make it one bigger after I'm done putting it in. That way, on the first loop, what I will do is I will put, so let's go ahead and type it out, I will put the first thing into the 0 slot, and then I'll put it in the first slot because on the next loop it'll be one bigger, and then etc. as we go. So we'll say here, name sub length. And I guess in advance, if I say sub, I mean subscript, because it's usually a like a subscript for an array is what the index is. So we have names array sub length, and then it's equal to the name that we have. Oops. There we go. So this will go to first the 0th position, right? Because if we were to loop through this, it's going to get the first name. The length will be 0. It will move the 0th element. It will set that equal to the name. It will make length 1 bigger, so it'll be 1 by the time it's over. And then on the next loop, assuming there's a first element, it will set that equal to the name, and then it'll make the length 2. So you see, it does properly keep the length. It tells us how many things are in there, and it does the setting before it makes the length bigger, which means that it will be in the length minus 1 spot, which, if you remember, right, we said because we start counting at 0, that if an array has some length, then the last index was always length minus 1. And so this should work. Here, let's go ahead and change VI that I was using, and then let's do one last thing. So let's print out all the names we got. Right, so here, let's actually move this afterwards, because I guess the nice thing about doing an array is that we can print the count now because we've read everything, and then we can go through the array and print everything afterwards. So this allows us, right, to store things that are related all together in one cohesive package instead of having to just immediately rattle them off right as we get them, right? That was kind of the limitation before arrays, is that if we had a bunch of aggregate data that was just all right after each other, we kind of had to use it immediately because we didn't know how to store it. And so this fixes that problem, and so now we can print out all these names. So here, let's just do a for loop. This will be very similar to the for loop I wrote in the last video. So for int I equals 0. Again, we always start counting at 0 with an array, so I think it makes the most sense to start here. And then we know that the length is how far we go. And I would encourage you to remember this, because this is pretty much how we'll write every single array traversal that we do. You always want to start at 0 and then go while you're less than length, because once we hit the length, we're out of bounds. Right, and all I want to do is I'm just going to print this. So, I don't actually need these curly braces. I'm just going to write one line of code. So I can just write that one line of code, and it will be in my for block. So here we're going to print name I. So I'll print I, and then a dot and a space, and then we'll print the name. So our array was called names array, right? We're going to need to go through, and we need to make sure we're using the array because the array is what contains all the names, and we're going to use the square braces to access each element. And here I'm going to access the ith element. So as a refresher from the last video, what this does, right, is I is going to be 0, and then 1, and then 2, and then 3, until it is less than length. So in our case, where we have 4 names, it will be 0, 1, 2, and then 3, and then that's the last one, because 4 will not be less than the length, because the length is 4 and it will break. And so what this will do on each iteration, right, is it will plug in I equals 0. So we'll get 0 here, it's going to print the number 0, and then it's going to get the 0th element in the names array, which will be this first one, Will Wetwood, and then the first one, right, it will go on the next loop, and I will be 1, so I'll grab the number 1, which is this one, and then it will print that, and then it will go and get the second one, and then the third one. And so we should notice that this will print out all the names basically in the same way that this example program did the first time we wrote it. Let's go ahead and compile and run this on Sally really quick, and we'll just see that it works. Okay, we're over here on Sally. I'm going to go ahead and compile. So I have something called arrays example, and we will compile that, and we will run it. So ./a.out, and then we said that the usage for this one was ./a.out, and then we were using argv1, which was the file name that we want to open. I still have the file from the last time we wrote this, so it should be a list of names.txt, and you'll see that it does it, aside from the end line, which I guess I forgot to put, but it does print like the number and then the name. So let's just throw it in end line so that it looks nicer for later. But right, all this does is it stores all the names all together in one single variable called names array. And so we can keep them all organized and all together and then come back to them later and grab them. So it's just a general overview of arrays. In the next video, we're going to learn how to look through the array and try to find things in the array so that we can store them and then look them up later.